Let's look directly at the environment. The experimental configuration of this environment topology will be discussed in the next class. The current requirement is to prevent PC1 from pinging PC2. Before realizing this requirement, first, ensure that PC1 can ping PC2. Then configure on this basis. If the network itself is unreachable, then you do ACL is meaningless. It must be based on the original normal communication of the network. Then based on some refinement, do some corresponding configuration for it. So you must ensure that the network is reachable. For this picture, let's talk about the configuration idea first. But don't configure. Make PC1 unable to ping PC2. That is, cannot ping this device from this device. If we go to ping, first of all, the two devices need to configure the address and gateway. For example, they both run OSPF through. Then how can we put some restrictions on it? Suppose now we have two ways. If I use the basic ACL to match the source IP of PC1, then we give it to deny. I make a configuration on the ingress interface of this device. As long as it is traffic from PC1, I give it deny. Then PC1 cannot ping PC2. But this does not optimize. ACL has a principle. ACL is as far as possible in the case of meeting the demand. Minimize the impact on other network. Now PC1 just doesn't want to access PC2. If under this interface, kill all traffic from PC1, then PC1 can't access R2 either. PC1 can't access R1 anymore. If R2 is connected to other PCs, PC1 can't access the following PCs either, because all its traffic is killed here. In fact, this does not meet our real needs. Our requirement is just to make it unable to ping PC2. It's not that it can't ping all other devices. So it is not very appropriate to use basic ACL here. For us, we can't use basic SL. The final effect achieved is that PC2 cannot be pinged. But other devices can't ping. It's not what we want. So we're going to use an advanced ACL here. Actually, we are at work. Including you will do a lot of configuration in the future. You will find the basic ACL uses less than the advanced ACL. Our more or finer matching. Because to determine the smallest range of influence. I'll give you a simple example. Let's take a look at the PPT. For example, now I hope to let this 1.0 network segment access the internet. But don't let it access the server. There are two options. The first one only grabs the traffic that wants to go to the server now. Then just kill the traffic. Suppose this server is on the 3.0 network segment. What I need to grab is some data in the network segment from 1.0 to 3.0. Then kill it under this interface. Then it will only affect the network segment 1.0 to 3.0. It can't access the server. But now if I now want it to not reach the server, I match the 1.0 network segment. The entire network segment is gone. Then kill it under this interface. Now this 1.0 network segment can't connect to the internet. Not only can it not access the server, I can't get online now. So this is not a real requirement. The same is true for this graph. Just don't want to ping it now. And don't want to have more control over some other range. So we now use the second method. Advanced ACL. It can match based on more parameters. For example, source IP, destination IP, and agreement. We don't actually use the port today. The whole NA stage does not involve too many ports. When we talk about NAT in the next class, I will talk about the port problem. In this lesson, we only need to look at these three parameters. The configuration including the next lesson is also based on the three of them. Now PC1 can't ping PC2. These are two hosts. I can limit traffic from 10.1 to 20.1. Guaranteed other data traffic. As long as the source and destination cannot be strictly matched. Then traffic will not be affected. Followed by the matching protocol. Ping uses the ICMP protocol. Right? There are two kinds of messages in ping. One is called echo. One is called echo reply. That is, one is request. One is reply. Actually, if the ping fails, it can be configured for both packets. For example, I'm here to kill its echo. That is, the request message. It is also okay to kill its reply message. Because ping is bidirectional. Data used to have to be returned. This message has two. If a message does not come back, it will not come back. But still that sentence. I prefer to kill the data when it passes. So we usually do some actions for ping. For example, ban ping. We are more based on echo to configure. Let me talk about its configuration ideas. We go up ACL on this device. Let it match the data from 10.1 to 20.1. And the protocol matches a subfunction like echo in ICMP. All future data from 10.1 to 20.1 want to use functions like echo in its ICMP. All will be denied by this interface. It cannot send this request. It means that PC2 cannot receive its message. Won't reply to it. Then it can't ping. Here are some rules corresponding between them. Let's talk about configuration in the next class. There will be a wildcard mask in the basic ACL. OSPF and EIGRP we talked about before. In fact, the anti-mask is used. At that time, I seem to mention wildcards with everyone. When we are doing basic ACL configuration, wildcards will be used. Okay. We'll stop here. Then we also hope that students can follow us. We are ThinkMo Education. I'm Grolin Annesley from ThinkMo. I hope today's content is helpful to you. See you next class. Bye classmates.